Hello, welcome to lesson C7, chemical families, and we're going to just start off right off by first of all, little things about the periodic table, including a vertical column of the periodic table is known as a group or a family, right? And so if we were to take a look, for example, at this column here, this would be a family. Now, this particular one is also known as the coinage metals, because they contain copper, silver, and gold. Now, a name for a horizontal row is known as a period. So, for example, everything in this column here that I'm just shading in, that is period number 5. So, horizontal row, known as a period. Vertical groups, known as a family. Now, the far left column, this column right here, is known as the alkali metals. Now, that name metals should kind of give you an indication that this one here should not be filled in because hydrogen is not really a metal. And so it's normally not seen as being part of this family, although chemically it does have many, many similar properties. Now, any family usually shares similar chemical properties, and these are known to be very reactive, right? Very reactive. They'll even explode in water. Such as sodium. So what I would like you to do is pause the video and first of all, name an element in the same period as sodium, as well as name an element that is in the alkali metals family other than sodium. So pause the video, give that a try. Okay, so in the same period as sodium, well, that would basically be elements 12 through 18. So magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, or argon would all be in the same period. Remember, periods are horizontal rows. Element in the alkali metals family would include lithium, sodium, potassium, rubidium, cesium, and francium. Remember, they're vertical, and we don't really include hydrogen in there because hydrogen is not a metal. Name given to column 2 is, or group 2, column 2, is the alkaline earths, or alkaline earth metals. Now, so those are these chemicals here, including like beryllium, magnesium, calcium, strontium, barium, or radium. Now, these are also known to be reactive, but not quite as so they are reactive, but not nearly as reactive as the metals in group 1. Just for an example, calcium When we place calcium in water, it does not wind up looking very much like that.
I'm going to demonstrate the reaction of calcium metal and water. In the tube there's probably about 5 mils of water, and all I'm going to do is place a piece of calcium metal in the top of the tube and watch what happens. So this again is a very exothermic reaction. What's happening is the calcium is reacting with the water.
Again, not nearly as dramatic as the sodium. Name given for column 17 is the halogens. Right? That's this column here. And these are corrosive nonmetals. So they're usually so corrosive that it's very difficult to find any of these within the family naturally, because it just reacts with almost anything. And again, that's like fluorine, chlorine, bromine, iodine. The far right column, this one here, group 18, is the noble gases. Right? And this is totally non-reactive. They are very stable. Now, that is why, we would want to, for example, fill our balloons with helium rather than hydrogen. They're both very light gases, but helium is non-reactive, where hydrogen, very reactive. So, question, name an element in each of the following groups or families: alkaline earths, halogens, and noble gases. Pause the video, look at your periodic tables, see if you can get these. Okay, so alkaline earths would include beryllium, magnesium, calcium, strontium, barium, and rubidium. Halogens, fluorine, chlorine, bromine, iodine. Now, arsenic is also in that same group. It does have some slightly different properties and is often not considered a halogen, but it is still in that same group. Noble gases include helium, neon, argon, krypton, xenon, and radon. So column numbers 3 through 12, those are known as the transition elements. Right? And so everything from 3 through 12, all of these things right here. And they're known for being quite stable and having multiple ion charges. Okay, which means that they can lose different amounts of electrons in an ion form, where many of the other elements cannot do that. Now the two rows underneath the periodic table, these ones here, these are known as the rare earth elements. And they can be identified as by the first two elements within each row. We've got the lanthanide series, because the first one is lanthium, sometimes put right here. And we got the actinide series. Again, sometimes put here. Sometimes you'll see these two pieces left off and put into here. Sometimes they're sitting right there. They're really just ways of formatting. But either way, the rare earths are put there with the lanthanide and actinide series. Really, they should be actually here. In this portion right here. But generally they do have the properties of group 3, and really it's due to spacing issues, because if you put them underneath, it fits much nicer on an 8.5 by 11 sheet rather than us trying to squeeze all of this in. And so really it is just the spacing issues more than anything else. That's why we put them underneath. Now, talked about hydrogen, really we've got this thing that we call a staircase. Now the elements in the non-shaded area left of the staircase, these are known as the metals. Okay. The metals are known for being quite shiny, malleable, ductile. Malleable means you can hammer it into a sheet. Ductile means that you can stretch it into a wire, and being good conductors. Now that would be both heat and electricity, right? And that's all these non-shaded ones here. We see that touching the staircase, flat surfaced, all of these dark shaded ones touching the staircase are not metals, as well as these kind of gray shaded ones are not metals. And again, we've talked about hydrogen. Hydrogen is quite difficult to place. Sometimes they will actually place it right here with the halogens. Sometimes you'll see it placed here because it's also not a metal. Now, the lightly shaded ones were the nonmetals. Now, they're known for being dull rather than shiny, rather brittle. Instead of malleable and ductile, they're quite brittle, meaning that if you try to flatten them or stretch them, they break or snap rather than just kind of mold to the force. And they're quite poor conductors of both heat and electricity. So what about these ones that are just touching? Now, with the exception of aluminum right there, all the ones touching the staircase they're known as metalloids. Which is really, they have characteristics that are a blend of metal and non-metal characteristics. And if this does seem all familiar, it's probably because you remember this song.
In 1869, Dmitri Mendeleev could see that properties of elements vary periodically. As atomic number increases, the properties repeat in a soothing rhythmic pattern that can form a funky beat. The elements we know about, they number 114. Some in quantities so small that they've never been seen. Most are common elements that are far and wide dispersed, but all of them together make up all the universe. Elements in group 1 are called the alkalis. They explode in water and are of very tiny size. They love to lose electrons when they form a bond. Of these reactive atoms, I can say I'm rather fond. Group 2 elements are often called alkaline earth. Calcium's been building bones since well before your birth. They form nice +2 ions and are generally quite fun, though they're not quite as reactive as the metals in Group 1. Since 1869, every one of us could see that properties of elements vary periodically. As atomic number increases, the properties repeat in a soothing rhythmic pattern that can form a funky beat. Metals in groups 3 through 12 transition elements. Some of them are lightweight and others really dense. Things they have in common, they form charges 2 or more. And some form colored compounds, which is something we adore. If you want an element, just tell me once again. If it's in group 17, you've got a halogen. Nonmetals so corrosive, they're not found in their pure state. They can gain electrons like they're going out of date. Got one for you in group 18, it's known as noble gas. If you're looking for an element that just sits there on its... If you wonder why and haven't figured it out yet, their valence configuration is a big stable octet. So now it should be obvious that everyone should see that properties of elements vary periodically. As atomic number increases, the properties repeat in a soothing rhythmic pattern that can form a funky beat.
Okay, so that's the periodic table. Your homework is pages 125, numbers 1 to 5. Have a great day. If you got any questions, let me know.